Hey, good morning, Algebra 1. Welcome to the first day of school for the 2020-2021 school year. My name is Mr. Rothery, and I'm excited to be your teacher to start off this year. Here's what I got for you. I've got to start you off with a lesson, okay? And this is not going to take our whole 2-hour block to go over, maybe take, 20 minutes or so. And we're going to talk about one-step equations, something that I bet you've done in the past, okay? And to begin, I want to talk about a couple definitions. Now, you'll notice that with this Google Classroom attachment where you got this video, there is also a note sheet. And you can do one of two things. You can print that off and kind of follow along and write things in as I'm writing them down. Or you can just do it on regular notebook paper, all right? And in the end, I'm going to collect it at some points, okay? So hang on to it for your studies, but I am going to give you points for your notes and everything that you write down as the chapter comes to a completion. Okay, so here's what I got. The first item that I have is an equation. And by the way, if you don't have that stuff yet, pause this. I'll wait for you. And then when you come back, have those items ready and unpause it, and we'll continue on. Okay, so, all right, equation. Here's what an equation is. An equation is a statement that asserts that two expressions are equal. Okay, now, what does that mean? Well, first, notice that the word equation has almost the word equal to sign in it. And an expression, I'll just write this down here, is an item like this. Okay? It's just some numbers or some variables or the sum or difference of numbers and variables. Okay? So I have 3x plus 2, that is an expression. And the important feature is that I have to have an equal to sign with it. Okay, so I'm going to put it equal to, let's say 8. Okay, so that is an equation. And again, the big thing is that I have an equal to sign there. Okay, and the part on the left and the part on the right are what we call expressions. Okay, so there is a difference between an expression and an equation. The solution, okay, which you see is the next part, is the value, or sometimes values, because we have more than one answer, we place in the variable to make an equation true. Now, if you don't know what a variable is, in mathematics, usually a variable is a letter used to represent a number, okay? And oftentimes it is x, okay? So in this case, it's the number that we would plug into x in order to make a true statement, okay? So if we try to think about what x could be, we could plug some numbers in, okay, and kind of guess and check until we work this expression to the left out and see what answers we got. Eventually we get an 8. Or we could actually do the hardcore math for it, okay, and solve this with a couple steps, okay. I think that if we played with this enough, we would figure out that x is equal to 2, okay. And this is actually a two-step equation, but typically we would subtract 2 to both sides. These would go away. 8 minus 2 is 6. And then we will divide. And I'll just say, if this made sense, this is harder than anything that you'll do for the rest of this lesson, okay? 6 divided by 3 is 2. If it didn't make sense, know that we'll be practicing this for a couple days. The inverse operation is a procedure that we do to get x or some other variable by itself. In other words, it's basically the opposite or reverse operation. Okay? You'll notice that this happened in a couple spots when we just did this math problem. Okay? I'll do this in blue, but when I looked at this first guy, this plus 2, the opposite operation of add 2 is subtract 2. Okay, so that is the inverse operation for addition. This 3x implies that it's really a 3 times x, okay? And the opposite of multiplication is this symbol here, which is division, okay? And so that's what inverse operations are. The last item is equivalent equations. Equivalent means that in some way they're probably going to be the same. Where are you at? There we go. And what it means is two or more equations that have the same solution, okay? Imagine this being the solution to the problem that I just did, and maybe I'll do a second one. X plus 1 is equal to 3. Okay? Very simple. What would X be in order to make a true statement? Well, yeah, X is probably 2, and we get that by subtracting 1 to both sides. Okay, but these two items here, and here are equivalent equations because they provide us with solutions that are the same. All right, if you have some questions on it, think about it, write those questions down, and then when we meet in Google Meets, you can ask some of those. All right, let's go on to their next slide where we'll do a couple one-step equations. Okay. Here I've got 5 of them. In fact, I'm blocking one of these, so I'm going to move my face out of the way to this side. That was fast, made me dizzy. Okay. And what I'm going to do is I'm going to solve these equations that have one step each. Okay. Your one step will involve one of these 4 operations. It'll either be a plus, a minus, a multiplication, or division. So we'll have to consider what opposite operations or inverse operations we're going to have with each one of these questions. Okay. Second thing is this, is that you are allowed to use a calculator. Okay, so if you have one handy, certainly take it out. I'll be the first to say that some decimals are kind of ugly to work with. Okay, some fractions are ugly to work with, and I'm more concerned about the process rather than whether you can do the number crunching perfectly. Okay, so have a calculator out if you'd like. If you don't have one with you, you can use your phone at this time, and this can assist you if you'd like. If you don't feel you need it, then great. All right, so here's what I do. I'm going to look at my first problem, and I'm going to put this little dotted line through my equal to sign just to kind of take a partition. And you don't have to do it, but I like to do it. And I'm going to ask myself which side is the variable on, or which side is the x on, and you can see that it's on the left side. And then I'm going to ask myself, what are we doing to that x? And you can see that we are subtracting 3. Okay. Now, the inverse operation of subtracting 3 is adding 3. So what I want to do underneath it is write that inverse operation, add 3. And if I do it to one side, that means I also have to do it to the other. Okay. And I'm going to put a line here. All right, now, the reason why we do that is because I know that when I subtract 3 and then add 3, they balance each other out and give you a value of 0. Okay, and if they give you a value of 0, all you have left is an x. Okay, I'm going to write my equal to sign and my -5 plus 3. Well, if you have 5 in the negatives and 3 in the positives, okay, those will cancel out, 3 of them will, and you're left with 2 left over. Okay, and what does that mean? That means that because your negative is with the bigger number, the 5, that your answer should be negative. Okay. Some people like to do this. They like to start off with this -5 somewhere on a number line. And you don't have to do this, but you can if you want. Okay, here's 0, 1. And again, you don't have to do this. But if you're at -5 and I'm going to add 3 to that, which is 1 spot, 2 spots, 3 spots, where am I at? Well, this is 0, this is 1, this is -1, this is -2. And so there's your finishing spot, okay? Lots of ways that you can figure that out. And again, if you want to put -5 plus 3 in your calculator, that is okay. Okay. Make sure you write a negative, not a subtract sign. All right, second one. I'm going to do this one the same way. I'm going to put a dotted line right down the middle where the equal to sign is. And I'm going to ask, where is the variable? Is it on the left side or the right side? And I agree with you. The variable is on the right side. And the number with that is 2.8. Okay, so what I'm going to do is I'm going to do the opposites of what I see here. And if I see an add, that means I'm going to do the opposite, which is to subtract. All right, and if I subtract 2.8 from one side, I have to do it to the other. And you'll finish with a y here because this guy and this guy will cancel. That's why you do that step. in 0.9 minus 2.8, put those in your calculator if you like, or if you realize that, hey, this is a positive and this is a negative, I have to subtract these two. That will give you a 1.9. And since your bigger absolute value of these two numbers is this bottom one, and it contains a negative sign, that means your answer is a negative. All right. So far, so good? I hope so. Let's move on to the next one. Again, I'm going to do the same thing. I'm going to put a dotted line right down the middle there. Oh, sorry. Oh, man. Cruddy. I got lost on my screen. I want to go back. Well, let me. Okay. Sorry about that. Sorry about that. Okay. It's my debut with this form of technology, so kind of a rookie there. All right. All right, here's what I got. What is with the variable? First of all, variables on the left side is your m, and it has an add 4.8 to it. So let me do the reverse operation of the inverse operation of adding 4.8, which is subtract 4.8. And again, whatever I do to one side, I got to do the other. Okay, your 4.8s are going to go away, and you're left with m, and then you're going to subtract these two. Okay, and if you subtract it, 9.2 minus 4.8, that's just basic subtraction. Let's see, 2, I'm probably going to have to borrow up here. Will leave me with a 4 and another 4, so 4.4. The bigger number is 9.2, and so because 9.2 is positive, so is my answer. Okay, I'm going to box this so it looks readable. That is an ugly box, and because I'm getting good at this, I'm going to erase that ugly box and do it nicely. All right, thank you for your patience on that. Okay, two lefts. Okay, again, I'm going to draw a little dotted line through the equal to sign and ask myself, what side is the variable on? What side is the n on? Is the left side or the right side? And of course, it's on the left side. And what operation are we doing to that? It is add 3. So let's consider the inverse operation, which is to subtract 3. Okay. These will go away, and I'm left with n is equal to. And let's think, -7 and a -3. Now, again, you are completely invited to use a graphing calculator, but there's -7, and if I have to go in the negative direction 3 more, 0's over here, the more negative direction is this way, so -8, -9, -10 is where I'm going to finish, okay? And again, you can use your calculator, that's certainly all right. Okay? All right, last one of this type, okay, is, and that's a subtraction sign, that's tough to see. You have a g minus 1/3 equals a -2/3. And again, I'm going to look at the side that the g is on, see what operation I have there. It says subtract 1/3. And what I'm going to do now is add a third. Okay, and I'll do that over here. These are going to go away. And you're left with equals g. And -2/3 plus a 1/3. Again, you're invited to use your calculator here. We'll do this off to the side. Sometimes it's easier to see. Remember, you do have a common denominator. That's kind of nice. That means you don't do that. It means you're going to put a 3 on the bottom. Okay. And let's see, -2, oh, that should be a plus, sorry. -2 plus 1 is -1. So your answer is -1/3. Put a box around that. And we are set. All right. Think about any questions that you may have, all right? Write them down and save them for our Google Meets, all right? And I'll be happy to discuss that with you. Now, one thing I want to point out is I said there were 4 different operations that we could have. Notice that we only used 2 of them. We only used the plus and the subtraction operation, okay? We didn't do any multiplication and division because there were no problems that had those operations with the respective variables, okay? Nevertheless, let's give it a try. Okay, as you look at these few, you'll notice that we start with a problem where the variable again is on the left-hand side. And I'm going to ask myself, what am I doing to this m? Okay, am I adding or subtracting or multiplying or dividing a 5 to it? And if you look, it looks like we're dividing by 5. Okay, that's what this bar on the bottom means. So the opposite of dividing or division is multiplication. So what am I going to do each side? I'm going to multiply by 5 to each side. Okay. That way, when you read 5 over 5, any number over itself will go away because 5 over 5 is 1, and you're left with an m. And then 4 times 5 is 20. Okay? And you'll notice that one sign is a negative and the other one is a positive. When the signs are different, then your answer is negative. So in these problems here, you're going to ask yourself, are the signs the same? If they are, then your answer is positive. If your signs are different, your answer is negative. It's a bad difference. There we go. All right, and that's what happens when we have these two things, multiplication and division. Okay, that didn't hold true on the other side, okay, the other slide that we did, but it will on these. Okay. All right, same idea. I have a 2 that's in my denominator, which means, again, I am dividing my n by 2. So the opposite, the inverse operation for division is multiplication. I'm going to multiply not only by a 2, but notice there's a negative out in front. So I got to keep the same sign no matter what it is with the n. So I'm going to multiply by a -2 here and a -2 here. The -2 over this -2 will leave you with an n. And -4 times -2, well, the signs are the same, so it's going to be a positive answer. 4 times 2 is 8. All right, now, if I look at the next one, it's a little bit different. I don't have this bar with a number next to it. In fact, I have this 13 with a z next to it. Sorry, not 13, 1.3 with a z next to it. We are going to imply that there is a times sign in between there when you do not see a symbol. Okay, so that is basically 13 times z equals 5.2. And since I'm using multiplication in this equation, the inverse operation is the opposite of that, which is division. Okay, so I'm going to now divide by 1.3. Okay. And so 1.3 over 1.3, those guys are going to go away. And 5.2 divided by 1.3, again, you can do that in your calculator if you want, because that's kind of nasty. It does give you a nice clean number. It gives you 4. Okay. Next one looks exactly the same. I have this times sign in between. Now that's a pi, it's tough to see, and this is also a pi. But again, I'm going to ask myself, what operation? Well, it's a times sign. The inverse operation from times is divide. And instead of dividing by like a 1.3 that you see here, you divide by what's with the x, which in this case, it's pi. The pi's will go away, and you're left with x is equal to. Now, -2 over -2 pi divided by pi, those guys are going to cancel out, and you're going to be left with -2. All right, so we got some answers here. Those all look pretty good. Again, I like to box them to let people know that these are my final answers. Those are my solutions. Some teachers like their students to use a highlighter to highlight their overall answer. Not important to me, but some students really like to do that, and you're invited to do that if you like. Okay. All right, 2 left. Now, you'll notice that I do have a times sign here with the x. However, you also notice that there's a division sign. Okay, you have a fraction. You have a 2 over 3 that's being multiplied by this x, which is equal to 10. And again, I'll cut this right down the middle. And what I'm going to do is something unique. I am going to multiply by what's called the reciprocal. Okay. A reciprocal is when you have a number like this, 2/3, and you flip it. and keep the sign, okay? So you flip it and just keep the same sign. So that's a positive, this will stay positive. And so if I have a 2/3 here, what I'm gonna do is multiply each side by the reciprocal, 3/2. When you do that, you're gonna have some nice cross canceling. These 2's will cancel, and so will those 3's. And you're gonna be left with an x. Okay. Now here's a tricky part, and this is where students sometimes make a mistake. People are good about knowing that we have to multiply these together. But what I do not do is we don't do this. We don't do 10 times 3 and then 10 times 2. Remember that there is an imaginary 1 there. Okay, so I will multiply across. 10 times 3 is 30. And on the bottom, 1 times 2 is 2. And then 30 divided by 2 is 15. Okay, if you like, you can do this entire part to the right in a calculator, provided that you show me that step. Okay, you have to write this 3/2 over here. Okay. All right, last one of this type is, let's see, what type of problem? Again, there's a times sign between the 3 and the p, and I need to do the opposite operation of multiplication, which in this case is division. Okay, so I'm going to divide both sides by 3. And you'll notice that there's already a division bar on this side, so I'm just going to put another 3 on the bottom. Okay, so these 3's will go away. I'm left with a p. The 2 doesn't have anything to multiply it by, so I'm just going to put the 2 there. And 3 times 3 is 9. All right, so again, all of these were multiplication and division, okay? And whatever multiplication part you had to do the inverse operation, which was divide. And if you had a division problem to start with, the opposite operation is to multiply. All right, write down some questions that you have. We'll talk about it in Google Meets if you happen to have some, okay? All right, next part. Really big question here. And actually, it's not a big question. There's just some strategies for solving word problems, okay? I know when we see these in our book, we look at those and say, you know what, I don't even want to try these. I'm going to skip them because they seem too intense, okay? But they're really not that bad. And you can read through these, but I think the ones that are most valuable are the ones that you see right here. Because I'm going to be honest, when I took Algebra 1, I was very much a more visual learner, okay? It wasn't about writing equations that I liked, but I liked making pictures, okay? I liked patterns. I like problem solving and sometimes working backwards. And these are strategies that we're going to use to help answer the questions that you see below, okay? First question says, in the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find the average speed to the nearest 100th of a meter per second. Okay, so what do they want to know? They want to know the average speed. And again, we have to address that part because they want to know what they're being asked. It's always the last thing that's in here. Okay, find the average speed. Okay, now off to the right, I have something called the distance formula. Okay, I'm going to write this for you. This distance formula is r times t is equal to d. This is rate. Rate is another name for speed. Times time equals, of course, distance. Okay, and so I'm going to use that way over here. I'm going to say, hey, rate times time equals distance. Okay, I'm going to get a darker color so that you can see this better. How about red? Okay. Now in this problem, they're going to give you numbers that represent two of these variables. So let's look. Usain Bolt won the 200-meter dash. Now let's ask ourselves, is 200 meters a speed or a time or a distance? Okay. And yes, I'm hoping that you're saying that 200 meters is a distance. Okay, so I'm going to write 200 over here. Okay, and then they give you another piece here. 19.32 seconds. Now, seconds is my unit. Is that a rate? Is that a speed? Or is that a time? Okay, and it actually is a time. 19.32 is a time. Okay, and so now we have a problem like we had on our previous slides, and we have to ask ourselves, what are we going to do to get r by itself? And I'm sorry, this should be a time sign. Okay, well, if we're multiplying r by 19.32, the inverse operation of multiplication is division. So I'm going to divide. Okay, and you can do that on a calculator, because I'll be honest, I can't do that in my head. And I'm taking out my phone and doing this real quickly because it's easier sometimes to do it that way. And I don't know what you get, but I'm getting r is equal to 10.35, because it says round to the nearest hundredth. And let's put it in the right units. It is meters, okay, per second. Okay. And that's that. Okay. All right, think about that. Pause the video if you need to kind of internalize it a little bit better, okay? And when you feel like you understand it and you're ready, you can move on to the next problem, okay? Okay, all right, now, say an athlete, let's say he ran 400 meters at the same speed that he ran 200 meters. How long would it take him to run 400 meters? Okay, now, again, I'm gonna go back to step one. What is being asked? And it says how long. So, oh crud, I didn't want to do that. There we go. How long would it take him? So when I think about rate times time equals distance, how long is a time? Okay. Now, what other items do they give us? Well, they do give us a new distance. They said, you know what? He is 400 meters race. It's a 400-meter race, so I'm going to write that in for the distance. I need to know the time. And it says that the rate or the speed is the same as it was in the previous problem. Okay, so I'm going to write that over here at 10.35. Okay, and then again, I'm going to ask myself, what do I need to do to solve for t? Well, again, I have a time sign here, so I need to do the inverse operation, which means I need to divide. Okay, and so when you do that, and again, I'm going to use my calculator real quick, 400 divided by 10.35, okay, gives you 30, not 200, yeah, 400%, 38.64. I think that would be a world record, actually. I don't even think he runs the 400 meter. He's just a 100, 200 meter man. Nonetheless, he is super fast. Okay, so in 400 meters, he can run that distance in this time. Okay, round your answer to the nearest hundredth of a second, and of course, this is correct, tenths and hundredths. All right, take a second, make sure that that makes sense. It seems a little odd that we're using a previous answer to help answer the new question. Sometimes they do that. Okay, so just kind of keep that in your head as you work through some of your homework. All right, again, pause this if you need to internalize a little bit better or ask yourself some questions in order to help make sure that this makes sense. And if it doesn't, then just put a little star by it. We can talk about it again. All right. All right, this is my last slide, okay, and it has two questions on it. And based off the strategies that were on the other page, okay, in addition to just knowing what they're asking, how many degrees, okay, what I want to do is sometimes draw a picture, okay? And so here's what it says. On January 22nd, 1943, the temperature in Spearfish, South Dakota fell from 54 degrees Fahrenheit at 9 a.m. to -4 degrees at 9:27. So basically in 27 minutes, it dropped a lot of temperature degrees, okay? And they want to know how many was that, okay? So that's what we're going to find out. How many degrees did we drop? And what I'm going to do is this. I'm going to kind of draw a picture. We have a little thermometer, okay? And it starts at 54. I like drawing pictures. And it drops all the way down to -4, okay? Now, something I like to do is that if I go from positive to negatives, I'm going to put my 0 in somewhere. I know 0 is right about Okay. All right, so how many degrees did we drop from here to here during that 27-minute period? Okay. So here's what I'm going to do. I don't know what that is. I'm going to call it T, okay, per temperature. And I'm going to start with 54. And if I'm dropping, then I'm probably subtracting some amounts that I don't know. And I'm finishing at -4. Okay. All right, and so what we got to do is figure out what do I need to do with this T, and it's a little awkward because this is kind of backwards for us, but the item that is with the T is a 54, so let us do the opposite operation. Now, some people say, hey, that's a subtracts, and it is, okay? However, the 54 has a symbol that is positive out front, so you're going to do the reverse kind of symbol of what you see there, and you will get this. All right. And let's see, a -4 and a -54, you can do those on a graphing, on a calculator if you like, but basically the signs are the same, and that will give you -58. Okay. And this isn't really a step we've done yet, okay, but we did try this problem this way. You do have a negative here, it's a -1, and the way you get rid of a -1 when you're being multiplied by a t is to divide. So the opposite of multiplication is division. And so you will finish with the bad arrow, sorry. T is equal to 54. Sorry, 58. This would almost make sense because if you think about this part, when we go from 54 all the way to 0, okay, this of course represents 54 degrees. And then when you go from 0 to -4, that's another 4 degrees. Okay, so you drop 54 just to get to 0, and then you had to drop 4 more. And together that does give you 58, which is what we have right there. All right, one more, okay, and here's what we got. It says, you thought the balance of your checking account was 68. Okay, so here's what I got. I just know that I started with 68, okay? When you go to your bank, so some time passes, okay, you realize that you forgot a recorded check, okay? So you have some check that took out some money, okay? Took out some money, and you finished with 26 bucks, okay? How much did you take out so that in the end you finished with 26, okay? So again, I'm going to subtract 68 because while there is a subtraction sign here, it's really a positive in front of that 68, okay? And we'll subtract 68 to both sides. Those are going to go away. And you got -c is equal to, if you don't like doing this, okay, you can use a graphing calculator or a calculator if you want. I say graphing calculator because I teach some classes where they use those. Okay. And remember when you subtract, you can't have the bigger absolute value of numbers on the bottom. You actually have to have it reversed. Okay. You have to subtract with a bigger number on top. So when you do that, you get 42. Okay, so flip those around so you subtract like we used to do back in 3rd or 2nd grade, okay? And again, we always pick the sign of the bigger number. So of these two, 68 is bigger, and so is this answer, okay? So that's also negative. And to get rid of your negative, I'm gonna put a 1 there, it's kind of imaginary. You're just gonna divide by -1. Okay, so your C is 42. You can check that. Is 68 minus 42 equal to 26? It certainly is. Okay. All right, now the biggest question that people have is this. With all the stuff that we did, I showed a lot of work. And you're going to ask, do I have to show these same steps as I did in my notes as I have on my homework? And the answer is, I'm sorry, yes. Okay. And while your assignment is on Clever, and you'll see your Google Classroom assignments posted, and I'll take you a link to Clever so you can log in and do your work. And you're like, hey, this is all inputted, digitally. I do need to see a sheet of paper with all your work neatly spaced and numbered off to the side that I'm going to have you submit. Okay. And that way I can give you some points for that as well. All right. So yes, you have to show your work. Yes, you have to take a picture of it or scan it in some way. And then again, you'll have to submit that work through Google Classroom, okay, under their respective assignment. If you have any questions on this, okay, I'm going to be in Google Meets, okay, shortly. And I would like you to ask questions if you have them. And you do have to check in. Okay, we do have to make sure that all students show up. So please make sure that that we make eye contact or speak or something, and I mark you down so that I know you're there. Okay, and then if after that you want to work on the homework, then totally cool with that. All right, but I'll keep the Google Meets open so you can ask your questions that way, and let me help you out if you need it. All right. I hope you have a great first day of school. And again, I'm really excited to be your teacher this year. And hopefully, more sooner than later, we can meet face to face once we are in a healthy state. And I'm looking forward to that greatly. All right. Have a great rest of your day.